welcome everybody in the Greenplum family to Greenplum Chat episode 2. And I want to kick it off by asking Frank, our PM for MADlib, what is Apache MADlib?
Apache MADlib is an open source library for scalable in-database analytics. It provides parallel implementations of math, statistical, and machine learning functions.
Okay.
So that's a short and sweet intro to it.
Sounds good. So we've been having MADlib for a long time. We just released the 1.9 version of MADlib just out the door.
Right.
Can you give us what do users get out of 1.9? What's in it? What can they use in 1.9?
Well, 1.9 is actually a very big release from MADlib. First and foremost, it supports Apache Hawk 2.0, which is the new, if you want to do a version of Hawk, which is coming out imminently. It's also an Apache incubating project. It also adds support for path functions, and path functions are a way of kind of finding your way through data sets, and we're going to demo that imminently. We've also added a complete rewrite of support vector machines, which is a classic element for supervised learning. We're going to demo. My colleague Xiaoqing is going to demo that as well as in this session. We've added support for advanced matrix operations. This is the phase 2 of matrix operations. First phase was done in 1.8.
So matrix, you mean like linear algebra calculations?
That's right. It's a wide variety of things. In this phase, the focus was on decomposition kinds of matrix operations, inversion, pseudo-inversion.
So you can actually do those linear algebra calculations inside GPDB and Hawk using the MADlib?
That's correct.
Okay.
So you use,
cool.
Yeah. And then just to finish up on 1.9, we added some additional statistical functions like covariance matrix and something related to the PCA algorithm, which is called proportion of variance. Anyways, a big release.
Yeah, and Frank, if you don't mind me asking, just for people who may not be familiar with Apache MADlib,
Sure.
Where did MADlib come from?
MADlib actually started at EMC Greenplum about 5 years ago in collaboration with UC Berkeley. So Joe Hellerstein, who's very well known in the database world, worked with some of the Greenplum folks with the idea of bringing machine learning into the database, right? So the idea is that you don't want to have to take the data out of the database, operate on it, load it back in. So it's a question of scalability and efficiency. So in addition to UC Berkeley, there's been collaboration with a number of other academic institutions, including University of Florida, Stanford University, and University of Wisconsin-Madison.
And out of curiosity, how is it now Apache, and why did you guys choose to take an open source approach to this?
Right. So we moved to the Apache community in the fall at approximately the same time that Pivotal open sourced Hawk, which became Apache Hawk. So it was partly related to having it work with Hawk, but also because the Apache community is really a great place for software developers to collaboratively work together in order to build innovative and interesting projects. MADlib has always been open source. It was under a BSD license before, but in the fall we moved to the Apache community.
So MADlib is machine learning, data science, very advanced analytics. So how can we break down for our everyday database users, what is this new path functions that we have? Can you guys help us really understand what is this path functions we implement, and how can users take advantage of it? What does it give them?
Okay. So the idea behind path functions is to perform regular pattern matching over a sequence of rows and then extract useful information about those rows. And that useful information could be a simple count, it could be an aggregate function, it could be a width function. And data science, we'll show an example for online shopping in a second. Data scientists can use this in a number of ways to, for example, prepare data for input into a predictive analytics algorithm, or there's another number of other functions as well. And it's used in a wide variety of use cases. It's used, the classic one is online shopping. That's where it came from, the web analytics space.
So does the path, when we say path and you say online shopping, what is the connection between that word path and the online shopping? How does it relate to each other?
It generally means a path through time by an item of interest, which is often, say, a user. So path functions are often associated with time series data.
Right.
So if one is interested in looking at, say, a user behavior, or in the connected car case, a car diagnostic codes, or in cybersecurity example, users touching servers, that's all paths through time. So the path functions, as Cesar well knows because he's worked in this space for so long time, is around identifying those paths of interest and extracting interesting information about them.
I think it's extremely interesting that actually we are having path analytics in the open source world now. I mean, it's I guess there's some vendors that are been doing path analytics or path functions embedded in the database, but from my point of view, the MADlib opportunity is the ability to have this in the open for the community to work on it. Have you found any interest so far in the community, or have you worked with the community at all on these path functions, or any plans to work with the community?
There is definitely plans to work with the community on this. I think the path functions are not actually predictive analytics, right? So it's not limited to people who are just, say, data scientists. I think people who are very interested in Postgres are interested in SQL and designing efficient SQL queries can contribute to path functions. So we're very interested and excited about having folks from the community contribute.
So I see you've got the screen share. What have you got up here?
Right, so I'd like to give a little demo, but before I get to the demo, I just want to give you a sense of the flow. And I'll talk about it kind of at the abstract level, and hopefully when we see the demo, it will become a bit more clear. So you have an info table, and you want to order that. You want to partition and order that. And the partition is often something, as I said before, like a user ID or a session ID or a car ID.
So let's say it's the web. You've got you've got a shopping cart, and you've got some specific user that's going through the website, right?
Right, they're going through the website, so you order it by
Just
time.
a question, with the partitioning that you have on here, would this be similar to the partitioning you might have of data across the nodes? And
No, this is totally different.
Got it, all right.
Well, the word partition here I'm using in the sense of path functions.
Gotcha.
But actually the distribution of the data across the segments is relevant here, because one would want to distribute the data in the same way you're partitioning the path function, because that would be the most efficient query execution, because that would limit the network activity.
So for example, then let's say you had a cookie ID for the user.
Yeah.
You would distribute the table on cookie ID, and then you would also be doing this quote path partitioning based on the cookie too. So you're tracking that specific user.
Correct. That would be the most efficient way to distribute your data for use in path.
Okay.
So we've got these ordered partitions. And then let's blow up, say, order partition 3. This consists of a bunch of rows, right? 1, 2, 3, 4, up to M. Then we're going to use this idea of symbols. And a symbol is something that you use to identify a row of interest. And once you've identified a row of interest, you can use a regular expression to figure out which matches you get against this ordered partition. So in the same way that a regular expression searches within text in order to extract the text fragments of interest, if you turn that 90 degrees, think about searching across rows within a database based on symbols that you've defined. Then you've extracted these matched rows of interest. Here I show a couple of groups of them here, but it could be many. Then you've identified them. You can do something interesting with them. You can count them. You can write aggregate functions. You can write window functions, etc. So maybe to make this a little bit more concrete, I'd like to go and run a demo now. So I'm just going to use a IPython notebook here, and I'm going to load some data. So let me load some data here.
So what kind of table is this?
Okay, so this is a log table. So there are, I don't know if people can see this, but this is a notional website that sells beer and wine. And a beacon will fire to the log file when the shopper visits a certain page on the site. Like they go to the beer selection page, they'll fire beer. If they go to the wine selection page, it will fire wine.
So every HTTP request is generating a log entry.
Right.
Okay.
Right. So this is the resulting log file that we see. So it's got a timestamp. It's got a user ID. This data is sessionized, so it's a session ID.
Right.
And the page is the actual kind of beacon that fired. So you can see there's a landing page or a splash page. This user shopped for wine. Another user came in the landing page. Then there's checkouts, which is purchases. Right. So it's a kind of simplified version of a log that comes from beacons firing on a shopping.
So I have a question. Session is
Sure.
a very common term. People
Yes.
understand it. Can you just describe it for the audience here?
Sure. A session, kind of as the name implies, is a period of time in which a user is doing some activity or a car is doing some activity. And it's time-based, and it's generally set up so that all activity that happens within a certain time period, say 30 minutes, is allocated to a session.
That's why you see the numbers repeating.
Right, it's like a web session,
It's
right?
not like a database. It's more like an app.
Right.
Pooling.
Right. So in the case of a connected car, you could say if you're on a drive, then you're seeing diagnostic codes firing over a period of time. You go and park and go shopping somewhere, and come out and drive again. Then another session would start. And dividing things into sessions is a common way to kind of understand behavior.
Okay.
So moving along with our example here. What we're interested in doing is we're interested in identifying sessions in which the user places an order within 4 pages of entering the landing page.
Hang on a sec, Frank. So you're
Please.
saying basically, for all the people who hit the website, how many of them it only took 4 clicks to get to what?
To get to purchase, to actually.
4 clicks to purchase. So you're dividing it. So these people were efficient, 4 clicks to purchase
Right.
out of all the people using the site.
Right, and I want to know what the checkout revenue.
And normal SQL without grouping and fancy, not grouping, but without path,
Yes,
right? It's not easy to create that kind of SQL, right?
it's not. I mean, you could actually write this in SQL, but it would be extremely messy SQL without this specific function to do this.
Okay.
And also we incorporate some stuff in C++ to make it more efficient.
Okay.
So let's look at the call. So this is the MADlib path algorithm. I'm going to give it the name of the input table and the output table. I'm going to partition by session ID, like we talked about. I'm going to order my partitions by time. And then I'm going to define a bunch of symbols. So these are the symbols that I'm defining. A landing page, a wine page, a beer page, a checkout page, and then an other page, right? Which is not landing or wine or beer. Or
How does
checkout.
it map? How do you mapping the symbol to the rows?
The symbol is mapped kind of behind the scenes, in which, so when the path function runs, it looks for hits against the symbol, and then it allocates the symbol to that.
It's like creating a variable, kind of.
It's kind of like creating a variable, and you can make those arbitrarily complex. So you can see that this is standard kind of Postgres definition.
Okay.
I'm saying that in this case, there's a lot of knots, so it's not. So you can make these arbitrarily
Okay,
complicated.
it's other. It's not this. It's not this. It's not that.
Right.
Okay.
So now comes the regular expression. So this is a regular expression, which essentially is saying start on a landing page and end on a purchase page, and in between do any other pages. That's what this means. So you can put arbitrarily complex regular expressions in here. And I want to sum by revenue, right? So I'm going to run this.
I have to ask you one question.
Yes,
What is
please.
this Jupyter thing? And can anybody use that?
Yes, Jupyter is an IPython notebook. Think of it as a Python client to kind of a wide variety of languages, including SQL. So what I'm doing is I'm specifying in the cell that this is a SQL statement. I can write standard SQL in here.
So from this UI, you're writing your SQL and then executing it.
Right. I can connect to a Greenplum server. I'm doing this locally now, so it's running on Postgres.
Cool.
Yeah. So what I see here is I've got my checkout revenue. So there was actually 3 sessions in which somebody made quick purchases within 4 clicks. Session ID 100 and session ID 102. There's actually 2. So this guy must have been on his way to a party or something because he bought $15 worth of beer or wine and then came back almost right away and bought $23.
Let me add that this is the signal that the path functions are trying to identify. You have 4 clicks. That's the signal that you are actually trying to solve with a pathing function, and which is the goal of this new functions.
Right. And so this is just sort of the output of the rows of that. I outputted the pattern matches, and you can see that. So, for example, 100, session 100, he or she went from the landing page, the wine page, to the checkout page. And our party animal 102 here went from landing to wine to checkout, and then came back to the landing page, looked at the help page, went to the wine page. And went to checkout.
Okay.
So this allows you to do a wide variety of path flow related things through data, including golden path analysis, which is another common thing in analytics.
That's pretty cool stuff.
Okay.
Okay, so are we ready to go on to the next feature?
Yes.
We talk about let's talk about SVM. It sounds fancy. What actually is SVM, first of all, and what have we done in the new release 1.9 to either create SVM or make SVM better for our users?
So thank you, Ivan. So SVM, as you all know, is a classic supervised learning algorithms for both regression and the classifications. So 2 particularly desirable features about SVM. It is robust in the presence of data noises, and it is widely applicable to a variety of data configurations. So one of our customers in financial domain services is actually using SVM as a part of their workflow for fraud detection.
So SVM, you're saying it's supervised learning. So that means, what's the difference again, just in a very quick, between supervised and unsupervised?
Supervised learning means you have to have the data labeled. It is compared to the unsupervised learning, which is like a clustering where you don't have any labeled data. And you also have this class of algorithms in between called the semi-supervised learning algorithms, which is widely used in recommendation system.
Okay, and you're saying the strength, one of the main strengths of SVM is it's resilient to noise?
Yes. And it is resilient to noise because of this maximize margin features, and also it is applicable to a wide range of data configuration, which we'll actually show in a demo. In a demo, I'm going to show you in a minute.
And did we have SVM in MADlib before 1.9, or it's a new algorithm for us?
It is. We do have the SVM available in MADlib, but for this release, we refine this the algorithms for solving SVM. Also, we add advanced features for SVM such that it can it becomes more powerful, as you can see.
So it's the same SVM, but better, stronger, faster, more robust.
Exactly.
Okay.
That's well put.
Okay. So, all right. So, do you want to show the demo of what it can do?
Yeah, I will be happy to. So let me first start this demo with a simple visualization example to show you how useful it is to have SVM in fraud detection. I'm gonna go ahead and run this cell, which will produce figures using MADlib SVM training functions. The first figure here, it shows a bunch of data points we use to train the SVM. Here, the points in red denote the fraud data, for example, and the points in blue denotes the non-fraud.
So wait a minute. So is that the known training sample of the existing data, or that's the future data you're trying to evaluate?
This is the known training data.
Known training data.
Known
Okay.
training data. So the task here is to draw a boundary, given this training data, draw a boundary to separate the fraud data from the non-fraud data.
Okay. And the fraud here is which use case you said it was? Loans?
Fraud data is the points in red.
No, but what is this data? This is about.
This is a synthetic data I created for
Okay.
this purposes.
Okay.
It's not. I'm gonna show for the next example. I'm gonna show you the real world data.
Okay.
All right. So the task is here, as I say, is to draw a boundary, which we call the decision boundary, to separate the fraud from the non-fraud.
Okay.
SVM in its simplest form, which we call the vanilla SVM, it uses a straight line to separate the fraud data.
Okay.
From the non-fraud. And then you can see actually in the last figure, it is impossible in this case to use a simple straight line to separate these two sets of data. But in MADlib, we build an advanced features into the SVM, which allows SVM to use a decision boundary that adapt to the shape of the data.
So can you show noise in this picture, this simple picture?
The noise is actually the 1 point in between the red.
So basically, the points that don't clearly go into one side.
Yes.
They're broken up.
Yes, that is the simplest case, and you can see that the straight line fails in this simplest case.
Okay.
And we
Okay, I see.
with the advanced feature in SVM, we can successfully detect the fraud data with 100% accuracy, as shown in these two figures in between in the middle.
So anybody who wants to have a data set to detect fraud for their big data, fraudulent activity across any use case, this could be usable.
Exactly.
Yeah, Marshall has a very specific question related to this. Is SVM in the simple form linear discriminant analysis?
It is not. It is different from linear discriminant analysis, and it is very well known in the community.
Is that a different algorithm to do the same thing but has different attributes?
In its simplest form, it's very similar. So there is the major similarity between SVM and the linear discriminant analysis, which is they both use straight line as their decision boundary. But here we go beyond straight line.
Okay.
We want to allow the more complicated shapes.
So is this one better for noise?
It will much more powerful, and it will be better for noise.
Okay.
So which I will show you in a more realistic data set, and you can see how powerful our new tool is in practice. I'm gonna go ahead and run this cell, and which will give us the data we use in
So
this
what is
example.
this? What is this example? This is I see homes.
The task here is try to predict the house pricing, the price of house which is under 100,000, and we are gonna use the features such as
You're predicting the value of the house.
value of the house.
So based on other house data,
Based on the features here, like tax, the number of bathrooms
so
it
you're
has,
creating
and the
this.
size of the house.
So for example, if someone was appraising houses, they could train this model and then put in new data and say, okay, that's the value of your home.
Right.
Okay.
And in
So
this
you could
case,
use this to detect bad appraisers.
The government could use this to create your tax for your house.
Yes.
Right.
Right. Exactly.
And actually, I think they tried to do that and they get it wrong. For me, in my case.
I'm sure you're paying too much.
Anyway, so let's generate the two SVM models here. The first one is the simple. We call the vanilla SVM with the linear decision boundary, and the second one, all of these same things that happens inside the database, and I'm using the MADlib SVM training function right now, and you can see it's very fast. And this one uses the advanced decision boundary.
So what happens if my data is 500 terabytes? Can this system handle that?
500 terabytes, you're saying?
Yeah.
For that, we have to rely on Greenplum and Hawk.
Right. No, but if you run this algorithm in Greenplum and Hawk on 500 terabytes, then it would still work.
As long as Greenplum can handle it, we can handle it.
Okay. Good.
That's really good because we have a bunch of Greenplum users watching your talk right now.
Cool. So go ahead. Produce the results from. Let's compare the results from these two models. The first result is from the vanilla SVM. Let's count the. So let's look at these two columns, prediction and actual column. and let's count the number of rows where the prediction is not equal to actual results. And we can see that there's 1, 2, and 3. So vanilla SVM, it got 12 out of 15 correct, which is not bad.
What do you mean vanilla SVM?
Well, which is SVM using linear decision boundary.
Only a straight line.
Only a straight line.
Is that like the previous version of SVM in 1.9 or 1.8?
That's yes.
Okay,
It
so
is.
it's the old SVM.
It is old SVM, but it is a classic form of SVM. It's
Okay.
not particular to MADlib.
Okay.
And I'm gonna go ahead to run final results from the SVM with the advanced decision boundary.
This is the new function that's in 1.9.
Exactly.
Okay.
100%.
And surprisingly, we got it 100% correctly.
Okay.
So
That's good because every false positive in a fraud detection is going to require manual work for an investigator to go investigate that fraud, which is going to cost money.
that's right.
And cause wasted effort. Right?
Especially if you have an automation based on the old algorithm that's 3 PO'd customers
Yeah, you're going to have
waiting for the manager to come.
You're going to have false positives, and maybe would you also have false negatives where you missed the fraud?
Yeah, that's possible.
Okay.
Yeah.
So accuracy is important.
Yes.
Okay. Is that the whole demo?
Yes.
Sounds
it is.
good.
Very cool.
All right, so so we've seen the new function for Path. We've seen the new function for SVM, better, stronger, faster. Guys, what's coming for MADlib coming down the road? I know you guys are working hard. So what's coming?
Right, so we're working on the next release, which is 1.9.1, and that, depending on community input and opinion, we would like to do somewhere around the end of Q2. And the things that are kind of being worked on, both at Pivotal and within the community, are improvements to the path function, and that's around supporting additional features like overlapping symbols, having like more than one symbol match against a row.
Okay.
Also multiple overlapping patterns matches as well. So there's a bunch of other things around path.
Okay.
We're adding a one class capability to SVM, which is very useful for novelty detection.
Okay. So improvements to the existing thing we just demoed, the Path and the SVM.
Right. Correct.
Okay.
Something else we're very interested in doing as well is adding a graph analytics capability to MADlib.
Wait a minute. So you're saying not using SQL, but using MADlib like a graph interface? What does that mean?
So we've been working with our colleague Jignesh Patel from University of Wisconsin-Madison, and he has published extensively in the effectiveness of solving certain graph problems in relational databases. So we've sort of taken that to heart and said, hey, can we implement a graph engine within Greenplum, which allows us to solve for a certain class of graph problems associated with things like cybersecurity. So we'd really like to investigate that to find out how easy it is to build those in MADlib, how they scale, and how large and how efficient they are to execute.
Would this be an entirely new graph engine that is part of our research, or is based on any other research that have been done in the market, like Pregel or?
It's actually using the Greenplum platform and the Hawk platform. So we're not bringing a new platform there. What we're planning on doing, and we're going to investigate, is storing vertices and edges in a relational form, and then doing a certain number of kind of graph operations on those, like PageRank, shortest path.
So in the back end, you're still storing relational data in a database, but
Right.
you're saying you're giving the users capability to query it as if it was like one of these specialized graph engines.
Right, because if you're an enterprise that is interested in, say, cybersecurity, you don't want to go to your IT guy and say, like, we need to procure this separate graph engine because we want to run these graph algorithms. We want to be able to run those on the infrastructure which is in place in either Apache Hawk or Greenplum, and be able to do that in a useful way.
That's cool. So what would be part of that MVP? Like, what would be the first touchdown on the graph?
I think we would pick a couple of basic algorithms, some maybe traversal algorithms, possibly page rank, implement them, and really get a good sense of scalability, because that will give us a sense of whether it makes sense to move forward and implement these broader set of these algorithms. And also to give the folks in the community who are interested in this work a chance to contribute and innovate along with Pivotal. So it's really a call out to the community for folks interested in graph, who have some background in that, or interested in learning about it. We'd love to hear you on the mailing list.
Sounds good. Greg, what's the call to action here?
Well,
What do we want people to do?
Well, we want people that are interested in trying out MADlib to download the Greenplum sandbox. If you are a Greenplum user already, be sure to download MADlib 1.9 from PivNet, and give it a swing. And then if you're interested in contributing to MADlib, go to Apache MADlib. You can Google Apache MADlib.
What kind of
for the
skill
site.
set do you need to contribute to MADlib?
I'll let Frank and Xiaochen tackle that one.
Right. So it's a wide spectrum. Let's say that you're interested in working on utility functions. You say you don't have a background in data science, but you want to work on utility functions. That would require somebody who has, say, SQL skills to do that.
Okay. So you're open to having people with just SQL to, if they want to chip in and make MADlib better, they can get involved?
Right. For people interested in predictive analytics, then they can work on core predictive analytics algorithms. For people interested in bug fixing in C++, they can do that. Or Python, there's a Python layer in MADlib. And finally, if folks just want to work on documentation and do small documentation improvements.
Do we have a list like for people to jump in, like where we could say, here, these are some cool ideas to get started?
We do. If you go to the Apache MADlib wiki, there's a page there called Getting Started or Contributions or something like that. And it lists about 10 or 15 starter JIRAs, which describe things for, like I said, from documentation through predictive analytics algorithms. So that would be a good place to start to look through those 10 or 15.
Very cool.
Where's the wiki? Is that a part of the madlib.incubator.apache.org site, or?
It is. I have it up in front of me here. It is apache.org/. Sorry, I guess I don't have it in front of me. But if you just search for Apache MADlib incubating, then you will find the wiki there.
Great.
Sounds good, guys.
We have a few questions.
What do we got?
Well, so this one was a while back. Marshall was asking, how does it get decided how functions get added to MADlib?
It's a community thing, right? So one thing about being an Apache community is you've got to be transparent. You're doomed if your roadmap is hidden. So you can go to the wiki and see what's on the proposed roadmap, which is things that we've heard on the mailing lists that we're working on here at Pivotal. But anybody can add things to MADlib. So it's not by any means closed. If somebody's
what things are we targeting? What do we want people? What would be like great for people? I mean, what's the goal of the MADlib altogether?
Well, I would say a combination of utility functions, which is helping make data scientists' life easier in preparing data. That's one.
At scale.
Sorry?
At scale.
At scale, yes. Core predictive analytics algorithms is the second one. A third one, which we're very interested in doing in 2016, is Python interface.
Great.
So defining, architecting, a really good Python interface for MADlib would be something I think that would be.
But in summary, this is a library for data science and analytics, right? On top of databases. Am I right?
That is right. The key persona here is is data scientists.
So anything that makes a data science become more powerful and can do more good work on top of their database, then that's fair game, right?
That's true.
Okay,
It's a good summary.
sounds
A
good.
couple more questions, if you don't mind. So we have a question from Marshall back to SVM. Xiaocheng wants to know, can SVM tell us the function used to predict? Is it a closed form analytic function?
In a linear case, it can. It's just a vector, but in a nonlinear case, it's slightly more complicated. But it's all the information you need is in the table, so you can access that with the model name of a prefix random.
And the other thing I'd add to that is we publish a design document with all of the mathematical background behind the algorithms. So if you go to the MADlib website, madlib.incubator.apache.org,
Craig, are you able to show that?
Yep, I can.
/design, I think it is. Yeah, just then do madlib.incubator.apache.org/design. That describes all of the mathematical implementation details. So if you look at chapter 15, if you look at chapter 18.
Going into where?
So that's the whole page of
Documentation.
MADlib, and then where do we go for the
/design.
/design.
Is that a hidden link?
No, it shouldn't be a hidden link. I have it up if you want to give me.
Does this explain the algorithms?
This describes everything related to how they're implemented. So what the MADlib team does, and other folks who work, is they look at the relevant literature, determine what the scale-out implementation of these algorithms is, and then they write a section of this document.
So is this living document that is always updated with whenever we add new algorithms and
Correct.
stuff like that?
Correct. So Xiaocheng just wrote the chapter on support vector machines, which is that one there.
Okay.
And the question that came up around nonlinear, just stop, Greg. The question that came up around nonlinear, if you went to page 140, whatever, there will describe the treatment for the Gaussian and polynomial.
Great. That's great.
This is pretty unique in the industry from the point of view that it's an open source data warehouse with an open machine learning library. No one is doing that right now. From my point of view, this is
No
amazing.
one else is doing that.
Yeah.
Okay. Greg, any more questions from the audience?
A couple of them. So Marshall was asking, he's apparently really excited about the upcoming graph functionality. He wants to know, when can you get it?
We said the MVP they're working on, right? So how small a chunk is the MVP?
It's going to be the first couple algorithms. So it's going to be
Over
as
the
I say,
next,
early
couple
phases.
months, 3 months, 4 months?
3 months.
Yeah.
End of Q2, early Q3 is when we're doing the next 1.9.1.
And that will have the MVP for graph in it. Likely.
Yeah, I mean, it depends.
Likely.
It depends how.
That's what we're working on.
Yes.
That's what we're working on. And as I say, folks in the community are excited about this. Definitely interested in
Okay.
the other.
Yeah, and I mean, anybody who's paying attention on the MADlib dev user group, they can see the progress on, when is the release actually coming,
Right.
when is the release motion happening. It's not like this is a big secret in the
Correct.
MADlib community. And there was one really great question on here from Andre. Andre is new; he's never heard of MADlib before. He wants to know: is this a replacement for R or a complement?
A good question. It's not a replacement for R.
Well, it's not a programming language, right? MADlib is functions, isn't that true?
That's true. But the point I would make around R is that if your data fits, and so MADlib is for large data sets. It's for data that does not fit in memory in a single node. If you have smaller data sets in which it fits in memory in a single node, then there's many other options for you. R is one. There's Python libraries like scikit-learn. There's a bunch of other ones out there. Really, the sweet spot for MADlib is extremely large data sets. So it's data sets that scale out. I would say MADlib is complementary to Greenplum and Hawk's platform. That's sort of how we.
So that's R, but we also have PLR, right? PLR runs in the database, but the main
Right.
difference is I think, is PLR is a programming language and R is a programming language. You can write any code in a programming language, right? But MADlib is a set of API functions you can call. They have an interface that says, okay, do this, do that, right? You can't write a program.
Well,
Is that right?
it's partly right. Now we do have an R interface in MATLAB as well, which is called Pivotal R. Probably will be renamed MATLAB R in the future. But that allows you to have more of a programmatic flow and allows you to write in the same way that you would write our data frames and our flows, data programming flows. You can call MATLAB functions from that as well. So I think the interface is, it's SQL based behind the scenes. The interface is part of the story, but it's really around size of data. I mean, size of data and efficiently operating on those large.